So we were till the making change problem yesterday, and we discussed what this problem says and how greedy algorithm actually fails to answer such a problem, where the optimization approach applies, but greedy is either not able to give the exact results or it gives the result, but that's not optimal. So that's why we are moving towards the dynamic programming approach to find the solution of such a problem. And we have told it yesterday that dynamic programming will definitely find the solution provided one should exist there. Means if there is a solution, DP will definitely give that solution to us. And now we will actually go deep into the dynamic programming, and we will take the example of we are having three denominations. Look to this screen. We are having, this is by the way also virtual. So we are having three denominations, D1, D2 and D3. This means that these are the different coins available to the shopkeeper. Coin of 1, 4 and 6. So the total number of coins he is having three of different denominations, and we are supposed to make a change of 8 rupees using those three coins. All right. So he has to give 8 rupees back to us using the available infinite number of denominations. But the goal is to keep the number of the denominations as minimum as possible. So in order to solve such a problem using dynamic programming, we will make a table, as we are actually following the tabular approach, because I have already said that there are two approaches in DP, memoization and tabular approach, and most of the times it's the tabular one which is being followed. So on this side, that's on the row side, we will take the number of the denominations which is available to the shopkeeper. So the denomination he is having D1 is equal to 1, D2 4 and D3 6. And on this side, means column side, we will take the total amount we have to get as a change from the shopkeeper, starting from 0. Starting from 0, from 1, 2, 3 until 8, because it is the 8 rupees which he has to give back to us. And we will assign an integer I is equal to 1, 2, 3 to these rows, just to follow this row number 1, 2 and 3. So as I said it yesterday also, this change problem is equivalent to the by this what we call as knapsack 01, but unbounded in nature, because the shopkeeper is having an infinite number of these coins available to him. So the first case is this one, 0. Means we will start from row 1. Row 1 is when I is equal to 1. So you need to imagine in your respective places that these two rows are not here. Row number 2 and row number 3 are not here. We are only focusing on I is equal to 1. So when we start from I is equal to 1, we are here at this place. So that means this is 0, which means there is nothing, the customer has not bought anything, neither the shopkeeper has to give anything back to the customer. Okay. So when there is nothing purchase made by any of the agents, so this column will be always equal to 0. No doubt the shopkeeper is having the denomination I is equal to 1, 4 and 6. But since there is no purchase, he does not have to give any change back to the customer. So this will be always equal to 0. Now we will move to this first. That means we have to give 1 rupee change to the customer. This is just as the copy of 01 knapsack, and we followed the same table in the same way even that time also. So those people who are imagination is bit, on the higher side, they can imagine that we are just in this row. We have not found those values. So now this column we have found it is equal to 0. Now we are here. So this means that the shopkeeper has to give 1 rupee back to the customer. And he is having available denomination of only 1 because we are in row 1 only. That means shopkeeper is having only 1 rupees coins. So we will take the case when he is having only 1 rupees coins available to him. So it is simple. When he is only having only 1 rupees, if he has to give 1 rupee back to customer, he has to use 1 coin of 1 rupee. जगह है? Yeah, you can. सीआर को डिस्टर्ब नहीं करना, बाकी सब चलेगा, ठीक है ना? तो उसके बाद we will move to this next, that's 2, which means shopkeeper has to make 2 rupees available for the customer, but he is having only one denomination, that's 1 rupees of coins. So he will need 2 1 rupees coins. He will need 3 here, he will need 4, 5, 6, 7 and 8. So if he has to give 8 rupees to the customer, but he is having only 1 rupees of the denomination available, so how many coins he need minimum is 8. Now the second case arises that we will move to the I is equal to 2, that is the second row. And when we are going to second row, we see the shopkeeper is having now 2 denominations available in his pocket, 1 and 4. Okay, like the same case we were taking in 0 1, first one row, then second. So when we take this second row, we had to exclude all the rows but not the first one, which we have already taken. So we had to take that one also into consideration. So that means the shopkeeper is having the denomination 1 and 4 available to him. So here it is already 0. So when we go to this column, means he has to give 1 rupees to the customer, and he is having denomination of 4 and 1. So 4 rupees is greater than 1. He can't give 4 rupees to him in place of 1. So again he will give 1 rupees one time. So that's why the minimum number of coins here will be also 1. And now he has to give 2 rupees, and denomination he is having 1 and 4. 4 he can't give, he has to give 1 rupees 2 times. Okay, you see the pattern how to fill this table. So the formula is actually, whenever the coin, initially we were having coin is equal to 1, then we have the coin 1 and 4. Whenever this new coin is greater than this sum which we have to make, this 4 is greater than this 1, 2, 3. Until here it's greater than. Until 3 it's greater than, okay? Just copy the previous row's value. This is the formula. If coin of I, which is the new coin which the shopkeeper has got, if that is greater than J, J means the sum which you have to make. Here we have to make 1, then we have to make 2, then we have to make 3. Till here the 4 is greater than all those. So just don't look towards what is there, just copy those values from above row. So here it is 0, it will get copied 1, it will get copied 2, it will get copied 3, it will get copied here. Now we have to make a sum of 4 rupees. And this 4 is not greater than this 4. So then we have to use another formula. There are different ways to find what will be the value actually here. Like one way is to find, we have to make a sum of 4 rupees. Okay, we have to give 4 rupees to the customer, and available denomination we are having 1 and 4. So what we can do, we can give a 4 rupees coin to him only one time. That's why 1 is here. Then we have to make 5. So we can give both the coins because we have to take both the rows into consideration. 1 coin of 4, 1 coin of 2. So we can give 2 coins to him. Then we have to make 6. So we can give 3 coins. 1 of 2, 1 of 4, 2 of 1. That's also equal to 6. And accordingly, that's also equal to 6, yeah, 3, 4, and accordingly 8. You see, when we are here 8, we had to give him 8 rupees. using the denomination 1 and 4. So we can give him 4 rupees, 4 coins 2 times. That's why 2 is here. So I have written those notes also here, what it stands. Like here, the 6 is here. It means the minimum number of 1 coin needed to make denomination, because we are in this row. D1 is equal to 1. You see 6 is here. So that means the shopkeeper is having only 1 rupee denomination available to him. When we go to this row, that's we are inserting 3 here. Minimum number of 1 and 4 means he is having 1 and 4. Both the denomination coin is available to him. And when we move to the this last row, 1, its minimum number of 1, 4 and 6 means all the coins have to be taken into consideration. So 2 rows we have filled. Now we have to fill the third row. So when we have to fill the third row, we know 0, 1, 2, 3, 4, 5. Till 5, our new coin is greater than all those values. So coin of I, which means 6, it is greater than the values till 5. Is it the new denomination which the shopkeeper is now getting in his pocket? Is the value of this coin greater than all those values? Yes. So just copy the value from above row. 0, 1, 2, 3, 1, 2. Till here. Now we had to make a sum of 6 using all the 3 denominations. That means he can use either 1, 4 or 6. So what he will do is that he will just give him a coin of 6 rupees one time. 7, a coin of 6 rupees one time plus a coin of 1 rupees one time. So do bar. 8, a coin of 6 rupees one time and a coin of 4 plus 4. Coin of 4 plus 4 2 times. So this last, as in the 0, 1 knapsack problem, we have seen once we get to this value, this one, in the last column, this last row. So we had to actually start from this last row and this last column. Whatever the value will be here, that will be the final answer. So that means in order to make a sum of 8 rupees using the coin is 1, 4 and 6, the minimum number of coins he has to make will be 2. Now you will see that why to make it so complex, even we initially know that yes, we can take, but you are taking the example of your brain, that's known to you, but you are now trying to program this, you are trying to actually make a smart software, and you are trying to make that software combine the minimum number of coins, and we had to go through all those steps. All right. So one more point to be noted before I will go to the next slide is that is just look at here. Yes, this place. You see, I am in the first row. 1 means the shopkeeper is saying only 1 rupees coins available to him. Now I give coin 4 to him also. So I am in this row. So until this 4 is greater than those values, the previous row values will be copied simply. So that means until 3, because 4 is greater than 3, the values 0, 1, 2, 3 will be copied as such till here. Okay. Now, when we have to insert this 5, insert means we had to make a total change of 5 rupees. We had to give 5 rupees change to the customer. So what is the actual formula? In terms of formula, I'm saying how we can program them that. So what we do when we have to make a change of 5 rupees, so I have written it here. When I share those presentations in your group, you can, in order to revise the things which we are discussing, I am noting all the points here. So that means entering 5 when we have to make a change of 5 here. So what I am doing, I am taking minimum of what? Because I had to take minimum number of coins. Minimum number of coins to give change to the customer. So I had to make change of 5 rupees. That means I had to make change of 5 rupees using minimum number of coins. So I will take minimum of da lecture da. So I was actually saying that we have to make a change of 5 rupees. And 5 rupees we had to make when we are having the denomination of 1 and 4 available. Because we are in this row. Here I had to make change of 5 rupees. So I will take minimum. So as to take minimum number of coins. But of what? Minimum of 5. Which means when I had to make a change of 5 rupees here. For the time being, I am ignoring this second row. I am ignoring the coin 4. You see, ignore this. I had to make change of 5, but here, using both the coins 1 and 4. So for some time, I will ignore this row. Means I don't have this coin 4 available. I am having only coin 1 available. Okay. So when I am having only one coin available, that means I will be needing 5 1 rupee coin to make a change of 5 rupees. Either this is the condition, or that means I am excluding this part for second coin, or the second case is that I am including this 4 also, meaning second coin. When I am including this 4, that means I am having the change of 4 rupees. And how much I had to give to the customer? 5. So I am including one copy of 4. Now how much I am remaining to give back to him? 1 rupee. So I will subtract this 5 from this 4 because I included its one copy. How much is remaining? 1 rupee. I will go to that, I'm in this, I will go to that one column here and I will find the value in that place. What is that? 1. So I will add that 1 to this already 1 which I had taken. So 1 plus 1, that will be 2. And it will give me minimum of 5 and 2. What is that minimum? 2. And that 2 will be inserted here. This is in terms of formula. No doubt you can find it definitely that I will take this 1 and this 1 means 2 coins. But in terms of formula, how will the program calculate? Okay. And similarly, I have shown one more example here. That's making a change of 6 rupees here. And the change is 3. Okay. So that means what I will do? What I will do is that I had to give change of 6 rupees to the customer. So first of all, I will imagine there is no, this 4 rupee coin is not in the hands of shopkeeper. He is having only 1 rupee coin. So what is the possibility? He can give 1 rupee 6 times. Either this means this he will directly copy. That means we are excluding this case. Or if we include it, that means he will include this 4 rupee coin also. So he has given 4 rupees to the customer. So remaining is 6 minus 4. That's 2. So let's go to the column 2 and we see the value there. Is it 2? So we just paste the 2 here plus this 1. 1 plus 2, 3. So 3 will be pasted here. And same way, all those values will be actually found using the same formula. And now when we found those what we call as the 2 minimum number of coins which will be available to the shopkeeper to satisfy the customers actually change. So if we had to find now which of those 2 coins will be, because we know it is 4 and 4, but for program I'm saying, but for software it knows that I need 2 minimum coins. But what are those? Is it 1 and 1? Is it 1 and 4? Is it 4 and 6 or 6 or 6 or 4 or 4? What is that? So for that, we will again use the logic which we have been seeing so many times in the previous lectures. What is that? We are here. The solution is this thing. 2. 2 is our solution. Okay, minimum number of coins. Is this solution from this row? Have we got the solution from row I is equal to 3? So we will take a pointer to the solution and we will see whether this 2 is in this row or it has come from the previous row. Definitely it has come from previous because the 2 is also here. All right. So we will take the pointer here. Now the 2 is from row I is equal to 2. So we will again check whether this 2 has come from I is equal to 2 or I is equal to 1. So we will check its value from first row. Has it come from first row? No. It's only in the row second. So we will take this 2 and we will take this row and take the denomination which is present in this row. What is that denomination? 4. What is the denomination at row 2? That's why we are giving these indexes to all the rows. When we are here in this row, which means this 2 has come from this row. So we will directly go to the denomination present in D2. What is that? 4. So we will take that 4. So once we take that 4, what was the actual sum we were supposed to give to the customer? 8. We have given 4 rupees to it. So 8 minus 4, that's equal to 4. So now we have to give 4 more rupees to it. All right. So what we will do, we are in this row, again in the second row. We will now go to the remaining amount. What is that? 8 minus 4 is equal to 4. We will go to the second row again. We are already in the second row and we will go to the fourth column. And we will find the value there. Fourth column and second row in which we are already there. That's equal to 1. Is it? So we will now see whether this 1 has come from some row which is above this. So this 1 is in row 2. Let's see whether this 1 we have got from row 2 or row 1. We will make the pointer up one step. Has we got this 1 from above row? No. This 1 is already from the row itself in which we are. So let's go to this row again and take the denomination which is there. So we take 4 one more time. So 4, we were having the remaining amount of 4 to be given to customer. When we took this 4 again, it will become 0. When it becomes 0, as we 8 minus 4, 4 we move to fourth column. When it becomes 0, we will make to 0th column. What is the value there? 0. Program will automatically come to know that I have given all the remaining balance back to the customer. And even if you feel it difficult to remember it like this, here are the formulas which are here given. That when I is equal to 1 means the first row, then we have to use this formula. When j is less than 1 di, we have to use this formula. And I have calculated the values using this formula also. Okay, C of 1 comma 1 means the first row and first column. It is equal to 1 coming out from those formulas. 1, C of 1 comma 2, 2, 3. And if you see the values here, which we have substituted here, it's 1, 2, 3 like that. Okay, so one who doesn't understand it in this way in which I have solved, he can also remember those 3 formula, and these 2 formula also give the same results. Like if we see, is the last column actually 1, 8, 2, 8, 3, 8, 4, 6, and 2. This is 1, 8, 8, 2, 8, 2, 3, 8, 2. So you can also get the results using the same formula also. And complexity of this algorithm making change problem is n into w, means number of coins which is given to us and amount which we have to give change to our customer, that's w. This is a demo of the program which we need to implement in the lab, most probably in the next lab, because already I have given the assignments to you. I hope the lab people would have completed that. So I want now to discuss about this last little topic before winding up the class, is that multi-stage graph. So we have seen so many graph analysis algorithms, single source shortest path, all pure shortest path, then with negative edge cycle, then with cycle inside the graph. So many techniques. So this is one of the applications also which come under the dynamic programming approach. So we are having actually the multi-stage graph is given, means there are those different stages. The nodes are arranged in 1, 2, 3, 4, and 5. So it is a multi-stage graph actually, the term is. And we have been asked to find out the path from this starting vertex to this final vertex. That's in between 1 and 12. In between S and T, we had to find a path which is minimum in a multi-stage graph type of. And there could be multiple number of paths. It's not necessary that there is only one path existing. There could be more than one, but that will be always having the minimum weight that will be equal. So if we find a path from 1 to 2 to 8 to 10 to 12, so it could be one way to go from here to here. There could be another path like from 1 to 5 to 7 to 9 to 12. So means multiple paths can exist, or even a single path can exist. If multiple paths exist, that means the minimum distance from here to here in different paths will be same. That will be of minimum in all the cases. So such problems actually we also solve using the DP approach. DP approach automatically means what? We have to build a table, save the data, particularly the ones which are getting repeated. So the repetitive sub problems we store in this table, and whenever we need to use them, we just take that values from the table itself instead of computing or recursively calling the function continuously. So if we look to this graph, we are having certain number of nodes and the edge weights given. This V1, V2, V3 on the top is the stage number. So we are having one vertices in stage 1, one vertices in the last, and in between there are multiple number of nodes or vertices in different stages. So we make a table here like this sort of. We include the total number of vertex from 1 to 12. Then cost means the amount it takes for us to cover the distance from going from one node to another. And D gives us the ultimate path, means through which node we have been able to reach, through which city we have been able to find this minimum path. Did we take it via Gandhinagar or some other city? So we note that city also. So via which mark we have been able to reach to the city. And the remarkable thing about this algorithm is that we started from here initially. That's from the destination vertex. We started with vertex number 12, is it? Which is the destination. So we will start in the table filling, we will also start doing from vertex 12. So what is the cost in going from 12 to 12? Is it 0? Yes, we are incorporating 0 here. And via which node we have been able to reach this 12 when we are in 12 itself? So that will be again 12. We are not changing actually the node. Then we go to the next adjacent connected nodes to this destination node. What are those? Node 9, 10, and 11. So these three nodes, 9, 10 and 11, these are connected this 12. And if we have to go to node 12, that's the actual problem statement, that we have to go to the destination. So if we are at node 9 and we have to go to this node 12, how much distance we have to do? 4. And if we are at node 10, how much distance we have to do? Is 2. And 11 is 5. And total in all the cases we are actually reaching to this destination, and we write that node here. Okay. So now initializing the table by those values, these nodes here. Now we start the actual algorithm. And what's that? That's this. Now we start from here onwards. We were at this stage. So this is stage 1, stage 2, stage 3, stage 4. So what we do is that we go to the stage 4 and we calculate cost of 4, 9, 4, 10, 4, 11. 4, 9 means that we are at stage 4 and 9 means the cost via now 9 vertex. And when we are at stage 4 and we take this node into consideration in order to reach 12, how much cost we need? 4. We are at vertex 4, we take node 2 into consideration to go to node 12. How much cost we need? 2. These are actually the syntax to represent. We are at stage 4 and node is 11. Node is 11. So the cost will be 5. Cost is 5. So that means we have calculated the stage 5, the stage 4. Now we have to go backwards because we are starting it from 12. We are moving toward from right to left. These two stages are done. What is left? Stage 3. Okay. So that's what I have written here, third stage. And what I had to calculate in third stage is that cost of this 3 will be for stage 3rd. And how many nodes are there in stage 3rd? 3 nodes, 6, 7, 8. That means I had to calculate 3 distances. And what are those? C of cost of 3 means stage 3 and node 6. Cost of stage 3, node 7. Cost of stage 3, node 8. And that's what I have written. Cost of 3, 6, 3, 7, 3, 8. And the formula for this is that when I focus my attention only on this node, that is third stage, node number 6, cost of 3, 6, that is equal to minimum of C of 6, 9. C of 6, 9. So that means I will see what is the cost it takes me from going from 6 to 9. Okay, cost from 6 to 9 plus cost of 4, 9. Cost of 4, 9 means what? The fourth stage and via 9, how much it takes to reach to this. See, in simple terms what I am doing. क्योंकि मैं स्टेज 3rd पे हूँ और मैं वर्टेक्स 6 से देख रहा हूँ कि मुझे 6 से 12 जाने के लिए मिनिमम डिस्टेंस कितनी चाहिए. चूंकि मैं 3rd स्टेज पे हूँ तो मैं इसको लिखूंगा कॉस्ट ऑफ 3, नोड मैं 6 ले रहा हूँ क्योंकि 3 स्टेज में मेरे पास 3 नोड है. तो इनको डिफरेंशिएट करने के लिए मैं इसको लिखूंगा 3, 6 क्योंकि मैं इस नोड पे हूँ. अब इस नोड से मुझे राइट साइड जाने के लिए बिकॉज आई एम मूविंग टुवर्ड्स 12. अब यहां से मेरे पास 2 रास्ते हैं. या तो मैं 6 से पहले 9 जाऊंगा और 9 से फिर 12 जाऊंगा, या तो मैं 6 से पहले 10 जाऊंगा, 10 से फिर 12 जाऊंगा, है ना. तो अब इन दोनों में चूंकि 2 रास्ते हैं, 2 अल्टरनेटिव्स है, अब इसमें से मुझे कौन सा रास्ता चुनना है? द वन विच इज मिनिमम. एंड दैट्स व्हाट आई एम टेकिंग दिस मिनिमम इनटू कंसीडरेशन. और मिनिमम जब मैं लेता हूं सबसे पहले मैं क्या देखता हूं कि मैं C of C, 9, 6, 9 6 to 9 means how much it takes for me to reach to this. I am taking this path initially. 6, 9 और 12 वाली पाथ मैं पहले लेता हूं, तो यहां से यहां तक मुझे कितना चाहिए और फिर यहां से यहां तक कितना चाहिए, वही मेरी डिस्टेंस है ना। तो 6 to 9 प्लस कॉस्ट इट टेक्स फ्रॉम गोइंग फ्रॉम 4 to 9, दैट्स फ्रॉम दिस स्टेज टू दिस वाया दिस वर्टेक्स 9 एंड सेकंड इज, चूंकि मेरे पास दो अल्टरनेटिव है, ये मैंने यहां से ले लिया, अब मैं इसको यहां से लूंगा, तो यहां से लेने के लिए मैं क्या करूंगा, फिर से वही फॉर्मूला, कॉस्ट फ्रॉम 6 to 10 मीन्स 6 और 10 के बीच में कितना फासला है ना, प्लस इन एडिशन टू इट कॉस्ट it takes for me to go from 4 to 10, that's fourth, this is fourth vertex, fourth stage and the vertex is 10. मैं 4 का मैं 10 क्यों ले रहा हूं, क्योंकि ये वैल्यूज मुझे टेबल से डायरेक्ट मिल जाएंगे, ये मैंने कैलकुलेट करके रखे हैं। सो अगर मैं अब इनकी जगह पे वैल्यू सब्स्टिट्यूट करूं, C 6, 9, imagine this is an edge weight, the weight of this edge 6, 9 के बीच में जो एज है ना, ये पाथ में ले रहा हूं, उसका वेट कितना है, 6 है, तो मैं उसके बदले में 6 ले रहा हूं, प्लस कॉस्ट इसको मैं ऐड कर रहा हूं 4, 9, और ये जो कॉस्ट है, जब सी होगा तो ये एज वेट है, जब कॉस्ट होगा तो ये वर्टेक्स का कॉस्ट है। सो 4, 9 किसके बराबर है, 4, 9 हाउ मच इट इज इक्वल टू 4, 4, 9 का मतलब क्या है भाई, कि मैं फोर्थ स्टेज पे हूं और वर्टेक्स 9 के जरिए इसके माध्यम से मैं यहां तक पहुंचने की कोशिश कर रहा हूं, सो दैट्स इक्वल टू 4, ठीक है, इसलिए मैं यहां पे लिख रहा हूं 6 + 4। अब प्योर हिंदी चलेगी यहां से, है ना, और इसके बाद मैं कॉमा तो ये यहां का ही है, अब मैं देख रहा हूं कि सी 6, 10, जब सी है खाली तो इसका मतलब है ये एज का वेट है, ये वर्टेक्स का नहीं है। सी 6, 10, 6, 10 का मतलब क्या है, अब मैं 6 से 10 यहाँ इस वाले रास्ते से जा रहा हूं, तो एज का वेट क्या है उस टाइम, 5 है ना, तो मैं इसीलिए 5 ले रहा हूं। उसके बाद कॉस्ट है फोर्थ स्टेज और वर्टेक्स 10, यहां से मैं जाता हूं, तो अब वर्टेक्स का इस टाइम क्या है, 2 ही है ना, तो इसलिए मैं 2 ले रहा हूं। अब ये 10 बन जाता है, ये 7 बन जाता है, तो मिनिमम क्या होगा, 7, और ये तो हमें ऐसे भी समझ आएगा कि अगर मुझे 6 से 12 जाना है, यहाँ से मुझे 5 + 2 7 ही लगेंगे, यहाँ से मुझे 6 + 4 कितना हुआ, 10 लगेंगे, तो मिनिमम पाथ ये वाली है जो मुझे 6 से सिलेक्ट करनी है। बट ये हमें, अगर हम कुछ देर के लिए इंसान हो जाए, है ना, ये तो हम इंसानों को पता है, सॉफ्टवेयर को तो नहीं ना पता ये सब चीजें। तो अब इसी 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 क्या बोलते हैं इसको, इसी तरीके से मैं कॉस्ट ऑफ 3, 7 फाइंड करूंगा, और उसका मतलब क्या है, मैं वर्टेक्स 3 पे ही हूं, है ना, और अब मैं वर्टेक्स 7 से देखूंगा कि 12 मुझे किस तरीके से नजदीक पड़ेगा। पहले मैंने 6 को लिया था, अब मैं 7 को ले रहा हूं, स्टेज अभी मेरा 3 ही है, स्टेज में चेंज नहीं कर रहा हूं अभी, क्योंकि अभी मुझे और कुछ नोड्स का फाइंड करना है। तो अब यहां पे देख लिया मजा क्या है, 7 से अगर मैं जाऊं तो मैं 7 से यहां से जा सकता हूं, है ना, फिर यहां से जा सकता हूं, इस 7 से मैं यहां से जा सकता हूं, फिर यहां से जा सकता हूं, है कि नहीं। तो आई कैन टेक द वैल्यूज इक्वल टू मिनिमम, मिनिमम ऑफ, फार्मूला वही है, मिनिमम ऑफ व्हाट, पहले मैं एज का वेट लूं, एज ऑफ 7 से 10 जाने के लिए, पहले 7 से 9 जाने के लिए, ये वाला मैंने इनको कलर कोड भी किया ताकि अलग अलग नोड का रास्ता अलग अलग दिखे। 7 नोड से 9 जाने तक कितना है, प्लस चूंकि जब मैं 9 पे पहुंचता हूं, ये कौन से स्टेज में आता है, 4 में, तो फिर उसके बाद स्टेज 4 से वाया नोड 9 12 तक जाने में कितना लगता है। सेम केस इज हियर आल्सो, तो मैं 7 से, यू आर गिविंग मी वेरी एनकरेजमेंट, यस, अगर समझ भी ना आए तो यस करते जाओ, ऐसे मुझे पता है आपको समझ आता है, इट्स नॉट, मैं जो, हाँ मैं मजाक नहीं कर रहा हूँ, मुझे पता है आपको, बट फिर भी जो एक बैठता है ना सामने, वो हाँ करता रहता है तो बंदे को लगता है मैं सही जा रहा हूँ, इसलिए सो आई एम वेरी थैंकफुल टू यू। ये तो हो गया कहाँ से 7 से 9 वाला। अब 7 से 10 वाला रास्ता मैं देखूंगा। 7 से 10 वाला रास्ता अगर मैं चुनूंगा तो मैं क्या करूंगा, पहले C of 7, 10 which means the edge weight, this thing C of 7, 10 plus cost in going from stage 4 via this node 10, 4, 10, 4, 10। सो अब इसकी वैल्यू भी जब मैं डालूंगा तो इसमें आएगा 5 plus 4, 4 plus 4 and 3 plus 2, this will become 8, this will become 5, so minimum will be 5। So I am updating this table also. We have to also take it into consideration, because when I found the path from 7 to 12, actually this is what my goal is. So this is the vertex 7. So I am getting the minimum equal to 5, means cost it takes for me to go to 12 via node 7 is 5, and that minimum comes via node 10. If you see this formula, so here I am getting minimum of 5, and that takes place via node 10. This is the 10th node. Okay, so in addition to finding the minimum cost, I am also finding the path which takes me or gives me this minimum cost. So this is done, this is done. Now which is left? This will become cost of stage 3 and node 8. अब यहाँ भी दो रास्ते हैं, ये 10 के जरिए भी जा सकता है, 11 से भी जा सकता है। तो अकॉर्डिंगली मैं फिर से वैल्यू सब्स्टिट्यूट करूंगा। अगर मैं फार्मूला की तरफ नहीं जाऊं, मैं डायरेक्ट यहाँ से देखूंगा। 5 और 2 कितने हुए? 7, 6 और 5 हो गए 11। इसका मतलब है ये पाथ छोटा है। सो इट मीन जो 8th नोड है, दिस इज द 8th नोड, तो मिनिमम डिस्टेंस क्या मिलेगी? 5 + 2 दैट विल बी 7। और वो कहाँ, किस नोड से मिलेगी? नोड 10 से। सो 10 इज हियर। So now it is become simple. Formula is given, you know how to calculate. So this stage is done, this stage is done, this stage is done. What is left? Stage 2. So then we will go to the stage 2. Accordingly, जब मैं stage 2 पे हूँ तो I had to find cost of 2, 2, which means cost of stage 2 and vertex 2. That's why 2, 2. Now यहाँ पे क्या है? यहाँ पे अब 3 रास्ते हैं। यहाँ पे भी जा सकता हूँ मैं, यहाँ पे भी जा सकता हूँ मैं, यहाँ पे भी जा सकता हूँ, है ना? 3 रास्ते जब मेरे पास है तो एक का हम देखेंगे वैल्यूज कैसे सब्स्टिट्यूट होंगे, तो दूसरा बाकी हम डायरेक्ट यहाँ से देखेंगे। C ऑफ 2, 2, सो इट विल बी मिनिमम। सबसे पहले होगा C ऑफ, ये होगा किसका? एज का, 2, 6। फिर 2 से मुझे 6 तक जाने का मैं एज का कितना लगता है, प्लस उसके बाद चूंकि मैं स्टेज 3 पे पहुंचा तो स्टेज 3 से फिर वाया 6 डायरेक्ट मुझे यहाँ तक पहुंचने में कितना लगता है ना? मिनिमम क्या है, तो वो मैं यहाँ पे सब्स्टिट्यूट करूंगा। कहाँ गया? ऐसे ही C ऑफ 2, 7, अब मैं 2 से लेके 7 वाले तक कितना है? दैट्स 2, और फिर 7 से डायरेक्ट यहाँ तक कितना है? V2, 2 से 8 तक कितना है? 1, और फिर डायरेक्ट थर्ड स्टेज से लेके वाया 8th नोड डेस्टिनेशन तक कितना है? सिंपल। सो वैल्यूज विल बी पुट हियर। So this way the second stage will be completed, and finally we will reach to this last one, which is our source. तो अब सोर्स से निकलने के लिए हमारे पास 4 रास्ते हैं, 1, 2, 3, 4। तो अब हमें इनमें से मिनिमम लेना है कौन सा, और मिनिमम कैसे लेंगे? हम लेंगे इसको लिखेंगे C ऑफ 1, 1। फर्स्ट स्टेज ओनली 1 नोड, that will be equal to, the formula is minimum of C of 1, 2, 1 से 2 जाने में कितना है, प्लस फिर 2 स्टेज से डायरेक्ट डेस्टिनेशन कितना है, कामा 1 से 3 तक कितना है वहां से डेस्टिनेशन, 1 से 4 तक, ऐसे कर करके तो हमें 16 मिनिमम आएगा। हमें 16 मिनिमम आएगा, और वो 16 हमें मिनिमम आएगा 2 नोड से, जो 2 एडजेसेंट नोड है इस 1 की। That's 2 and 3. That's why I have written 2 and 3 here, which means the minimum distance from 1 to 12 comes into play using via two nodes, node 2 and node 3, है ना? सो अब हमारे पास ये टोटल का टेबल बन गया, ये वाला टेबल। अब इस टेबल को हम ले जाएंगे कहाँ पे? इसको हम ले जाएंगे यहाँ पे। अब इसको हम ले जाएंगे यहाँ पे। So actually this becomes our general formula, है ना? I have written the general formula here, which we actually use, that if we have to find the cost in between the two vertices I and j, we take a minimum of what? That we take firstly the edge cost, only c is here, only c. We take the edge weight from j to some intermediate node, which is the next node in some other stage, and then cost from that I plus 1 to l. This is what we have been doing. Okay, ये पूरा का पूरा फॉर्मूला ये है इस पूरे एल्गोरिथम की। तो अब मेरे पास क्या है? अब मेरे पास अब हमने डिसीजन लेना है। वी टेक द डिसीजंस टू रीच फ्रॉम सोर्स टू डेस्टिनेशन यूजिंग द सीक्वेंस ऑफ डिसीजंस। और वो सीक्वेंस ऑफ डिसीजन क्या है? वी टेक this equal to stage number d of this is the stage 1 and this is vertex 1. इसको हम कल करेंगे, मैं थक गया है ना। भूल जाता आदमी, इसमें क्या है? इसका मतलब है अभी इंसान ही है।